All right, word problems. Now, I'm not going to deny that some of these problems are a little bit confusing and they kind of stretch our thinking, but we'll be able to get through them. So, number one, a dog is 50 meters from a tree. He angles his head up to the top of the tree, forming a 48-degree angle of elevation. How tall is the tree? The dog is half a meter tall, and then we're going to round to the nearest meter. So we have over here a tree. I'm just going to call it, there's my tree. And then I have my little dog. And we'll call that the dog. That looks kind of weird, but that's the dog. He is, how far away is he? 50 meters away. He angles his head up to the top of the tree, forming a 48-degree angle of elevation. So what's kind of tricky here is here's his normal line of sight, and then he angles his head up, and then he says there's a 48-degree angle of elevation there. And here would be our right angle. How tall is the tree if the dog is half a meter tall? So this is 0.5 meters. All right, so to grab that green triangle out here and to look at it, here we have 50, and here we have 48, and here we have our x. So our angle, and then we have opposite and adjacent. So I'm going to say, well, tangent of 48 is x over 50. So x is 50 tangent 48. What is 50 tangent 48? Well, that is, oh, what is that? 55.5, and we will round that to 56 meters. Actually, no, let's not round that yet. I'm sorry. Let's leave it as 55.5. All right, so we said that this piece here is 55.5. We also have this bottom piece, which is 0.5. So now to finish it up, I'm going to take, well, 55.5 plus 0.5 gives me 56 meters. Right? And what I accounted for there with the 0.5 was that the dog's head is half a meter off the ground. Right? All right, number two. A wooden beam measures 6 meters long and is leaning against a wall to make an angle of 71 degrees with the ground. All right, so let's read that again. A wooden beam 6 meters long leans against a wall. Let's draw our little wall. Here's our house. We'll say that this right here is our wall. Let me draw the ground too. The wooden beam leans up against the wall. It is 6 meters long and makes an angle of 71 degrees with the ground. So here is 71 degrees. How high up the wall to the nearest tenth does the beam reach? So we want to find how high up the wall there. So hopefully our house is square, so hopefully there's a right angle there. So this will be the side opposite. Here's the hypotenuse. So opposite and hypotenuse is sine. So I'm going to say, well, sine of 71 degrees is, well, opposite, we'll say that's our x over 6. So x equals 6 sine 71. And I type that in, 6 sine of 71 is going to be we'll say 5.7. And what is this? This is meters. This is meters. All right, there we are. All right, number 3. Sometimes telephone poles have guide wires to stabilize them. One guide wire is attached to a stake in the ground 20 foot from the base of the pole. The guide wire makes an angle of 22 degrees with the pole. Find to the nearest foot the length of the wire. So we've got a telephone pole here, right? And it's on the ground. It's a right angle. The guide wire comes along here. It's 20 feet away. And we want to know how high up the pole it is, right? Find to the nearest fourth. Oh no, we're supposed to find how long is the wire. We're told that the guide wire makes an angle of 22 degrees with the pole. So right here is going to be our 22-degree angle. So here's our angle, here's the side opposite, here's the hypotenuse. Opposite and hypotenuse is sine, so I'm going to say, well, sine of 22 equals 20 over x. All right, so x is going to be 20 over sine 22, and I type that in my calculator. 20 divided by sine 22 gives me, well, x is going to be 53.3, or 0.38, so we'll say 0.4. All right, let me double check on that one. Yep, that's what I said earlier. And I think I'm supposed to round to the nearest foot, so I'll say, well, that's 53 foots, or feet. The last one I might have been, yep, the last one I was supposed to round to the nearest tenth. Okay, we're good. All right, number 4. I'm at the top of a 190-foot lighthouse looking at a boat at sea. Oops, that's the wrong sea. Oh well. The angle of depression is 34 degrees. Find to the nearest foot the distance from the boat to the foot of the lighthouse. So the angle of depression means the angle down. So let's draw this scenario. Here's the lighthouse. So here's me staying at the lighthouse. It's 190 foot tall. And here's our little sailboat. We're supposed to find the distance from the boat to the foot of the lighthouse. So here's our x. And now for the angle of depression. Angle of depression is always looking down. So if I'm standing here, here's my eye level, and then here's the angle of depression, 34 degrees. Right. The angle of elevation would be here, the boat looking up at me. The angle of elevation and the angle of depression will always be the same. So we could say, well, this is going to be 34 degrees. Another way we could have done this is we could say, well, right here is a right angle. So if I take 90 minus 34, that gives me 56 degrees for right there. You can do them either way. It doesn't bother me. So I'm going to use the 34. And the 34 will tell me to use tangent. So I'm going to say, well, tangent, don't make this orange. Tangent of 34 is going to be 190 over x. So x is 190 over tangent of 34, and x is going to be, well, 190 divided by tangent of 34 is 281.7. Right, and I'm supposed to round to the nearest foot, so we'll say 282 feet. All right, there we are. Number 5. A straight road has a 12-degree angle of elevation. The road is 2,500 meters long. Find to the nearest 100 meters the height or the elevation of the hill. So what we've got here is we've got a road that goes uphill. So here's our road. Yeah, that doesn't look very pretty. So this is our road with 2,500 meters long. And we're supposed to find the elevation. Elevation is how far off of level it is, or how far off of ground level, however you want to word it. And this would have to naturally be a right angle. The road has a 12-degree incline. And there we are, our problem is set up. Here's our opposite, here's our hypotenuse, so that's going to be sine. So sine of 12 is x over 2,500. So x is going to be, well, I type in my calculator, 2,500 sine of 12. And I get 519.8. And how am I supposed to round? Find to the nearest 100 meters. So if I round to the nearest 100 meters, I'm going to round down to 500 meters. All right. Number 6. Find to the nearest degree the angle of elevation of the sun when a person 170 centimeters tall casts a shadow 170 meters long. So you've got a person here. Their shadow lays down here, and there's an angle going up here to the sun. Angle of elevation is always from the bottom up. That's going to be down there. So here is 170, and here's 170. And really, just from this, we should be able to know the answer is going to be 45. Because if the legs are equal, then it's going to be 45 degrees. So let me just write down 45 degrees. We know that's our answer. But I'm going to do the trig work just in case. Just so that whenever there's a problem that we can't do it that way, we know it. This is going to be the side opposite and the side adjacent. Here's our x. So I'm going to say, well, tangent of x is 170 over 170. So x is what is tangent inverse of 1 is 45. There we are. All right, number 7. The top of a 40-foot ladder touches a point on the wall 36 feet off the ground. Find to the nearest degree the measure of the angle the ladder makes with the wall. So here's our house, and we've got a ladder leaning up against it. The ladder is 40 feet long, and it touches a point on the wall that's 36 feet off the ground. So this is going to be 36. Find to the nearest degree the measure the angle makes, the measure of the angle that the ladder makes with the wall. So our x is going to be right there. So this is going to be adjacent. There's our hypotenuse. So I can say, well, adjacent and hypotenuse is cosine. So cosine of x is 36 over 40. So, x is cosine inverse of 36 over 40. And whenever I type that in, cosine inverse of 36 divided by 40 is going to be 25.8. So what am I supposed to find? Find to the nearest degree. So this is going to round up to be 26 degrees. All right, there we are. In a playground, a slide that is 9 meters long runs over a horizontal distance of 6 meters along the ground. Find to the nearest degree the angle the slide makes with the ground. All right, so we've got our slide that is 9 meters long, runs along the ground 6 meters. And we're supposed to find the angle it makes with the ground. There's our x, adjacent, hypotenuse. So cosine of x is 6 over 9. X is cosine inverse of 6 over 9. So cosine inverse of 6 divided by 9 gives me 48.2. And I'm supposed to round to the nearest degree, so I'll say 48 degrees. All right, number 9. Find to the nearest degree the angle of elevation of the sun when a person 170 centimeters tall casts a shadow that is 220 centimeters long. So this is a lot like a problem we already did. Here's the person. Here's their shadow. The person is 170 tall and 220 is their shadow. The sun is up here. Here's the angle of elevation. That's our x. So I'm going to say, well, this is opposite. This is adjacent. So that's tangent. Tangent of x is 170 over 220. So x is tangent inverse. I'm just going to reduce here to 17 over 22. And I type that in. Tangent inverse of 17 divided by 22, 22 is going to be 37.7. And what am I supposed to round to? The nearest degree, so I'll say 38 degrees. All right, there we are. Those are trig word problems. Make sure that you know how to do these, because there will be one on your test that is something very similar to a problem that's on this worksheet. So, all right, there we are. Bye-bye.